Good afternoon, everybody, and welcome to this presentation about the challenges of writing a Spring Insight Bootstrap loader. And we will look specifically into the challenges of doing that with WebLogic as a case study. This doesn't work. Oh, this one. So basically we'll cover three things. First, I'm going to talk a little bit about what is Spring Insight and what benefits you can gain from it. Second, we'll talk about what does it mean to add support to an application server inside the Spring Insight framework. And last but not least, my colleague here, Talya, will talk a bit about her experiences in adapting the Spring Insight solution to the WebLogic application server as an example. Sorry. A few words about who we are. I'm Lyor. I've been a member of the Spring Insight team since May 2010 when I did a POC with Spring Insight. I've developed the initial solution for what we call the BootStrap instrumentation loading of application servers for the Tomcat, the JBoss. I've done some initial research into WebLogic and also into WebSphere. My colleague Talya here, she joined Spring Insight in November of 2011, and she has been primarily involved with the WebLogic solution, as well as doing a lot of integration work with another product called the vFabric App Insight. And there is a reason for the similarity in name that builds on the capabilities of Spring Insight as a data source for its own functionality. Again, Spring Insight is also a standalone product and a standalone solution that you can use, but you can also integrate it with App Insight to get even more value from it. So basically, what Spring Insight is, it's an instrumentation framework that provides visibility into runtime. It's a big sentence that basically what it means is that once you install Spring Insight, you can leave it installed in your application server and constantly monitor what your application is doing. How well is it doing it? What are the main focal points? What are the main APIs of interest that your application is going through? Why is it doing that? How long is it taking? And some other interesting stuff from it. So basically we're using what we call a pluggable architecture that is defining these APIs of interest, and it's important to understand that we are only monitoring the APIs of interest that have been defined for the framework. This is not a profiler, okay? A profiler is mainly a development tool that you use if you have concerns about what your application is doing. You're allocating resources and you're not releasing them. You have some hotspots in your methods, stuff like that. This is not what Spring Insight is. Spring Insight is focusing on showing you what your application is doing only in those APIs that you define that are interesting to you. And these are the plugins. And the good side about it is that in contrary to a profiler, you can install it not only for your development needs, you can just install it on your production application as well. It is the same application that is actually servicing your users. And it keeps running in the background and collecting information. And for example, if you use vFabric App Insight, it can report this collection, this data that it has collected to the vFabric App Insight, and you can get alerts that your performance is deteriorating, for example, or that your users are starting to get long response times. Again, this is not what Spring Insight does. Spring Insight provides the information that you can use then to build these notifications. Now, the way that Spring Insight is doing that is it adds something like a layer between the application server and the actual applications that are running, and this layer does what is known as instrumentation. What we're doing is we're using aspects with the Aspect-J open source project that define these APIs of interest. We intercept them. We do some measurements, how long did it take. We extract interesting information from these APIs. Each plugin, for example, especially for HTTP, extracts very useful information that helps you not only visualize what is going on, not only you are able to tell, well, my application has gone through these call sequences, this code flow, but also what were some interesting parameters from it, how long did it take, what did it call next, again, each plugin has the opportunity and there's the chance to decide what is being extracted, what is being displayed. Like I said, it integrates with vFabric App Insight, but as a developer, we also provide what we call a built-in dashboard. What you actually are seeing here, the Spring Insight instrumentation is like an agent. It collects information, and at some time, it needs to report back what it has collected. Now, one of the targets of this collection can be the dashboard that you can use for your development needs, meaning you can see what is going on. Oh, sorry. And here you see an example of the dashboard. You get some very nice graphs about, response time and invocation count and other metrics that you're collecting. You can see the applications that are currently deployed. They are painted. We have a health, a response time that you can also define. What is a healthy application? How long did it take? What is the response time? Stuff like that. But not only that, we can also, sorry, I keep pressing the wrong button. But we can also give you samples of the actual code stack. What happened, what were these APIs of interest that were visited when you were doing that, and how do they break down? For example, in this case, you see the classic Spring sample application called Pet Clinic, for those of you who know it. And what you see here, for example, is the startup sequence of Pet Clinic. What does it do when it starts working? And you can see that it does a bunch of JDBC calls in this case. And you can see that out of the 8,334 milliseconds that this initialization sequence took, the vast majority was taken from some time between the time that the application was deployed, in this case the Tomcat, an Apache Tomcat, until the servlet context initialization started. Somewhere around there was spent a lot of time. Also, you can see that the Bean, the data source initializer that is responsible for populating the database, also spent quite a lot of time doing these JDBC calls. But you can also get the breakdown of each JDBC call. How long did it take specifically? So if you're a developer and you're running your application, it's not Profiler, but you run some scenario. Okay, I'm getting reports that when users do this kind of operation, they're getting a long response time. Why does it happen? So you can get a breakdown and see, well, I'm doing a bunch of JDBC calls and this statement is taking too long. Okay? There are other upsides. So there's, like I said, we also extract some other information. When I'll talk about HTTP requests, which have a very special meaning in Spring Insight, I'll talk about this information as well. So how do we achieve this? We do what we call bootstrap instrumentation. Basically, what we do is we ensure that all the relevant class loaders that load your application know about our collection plugins and know that before they load the class, they have to go through our collection plugins, which are aspects, and allow us to modify the bytecode so we can intercept these APIs of interest. Okay? This is an important point. We're using AspectJ. Those of you who know how AspectJ works, we're just using bytecode instrumentation, BCI. And the way it is being done is we define these aspects that detect and identify these class loaders of interest and say, well, you're a class loader that is going to participate in my application. I need you to know that any class that you load needs to go through my transformer that needs to scan it and decide whether it contains any APIs of interest that I need to instrument in order to collect the data. Another thing that we do as part of this service, the Spring Insight, is we generate the deployment lifecycle events. Like you saw, the Pet Clinic startup event. We identified the cycle inside the application server, it deploys your application and it starts calling all these initializers and stuff like that. It can even decide to undeploy your application. So we identify these life cycles and generate proper events. So for example, if you're experiencing long initialization time, you can also get a breakdown like I showed in a Pet Clinic example. Why does it take for my application so long to start? Maybe it's very responsive, but it takes 20 minutes to start up after reboot. Yes?
This suggests that it's actually bootstrap at load time of the container.
Yes. We do load time weaving. In other words, you don't need to compile your classes anyway special. You generate your project, your classes, your war files, your ear files, any way you like. using your tools. We don't ask you that you compile it in a very special manner or anything. We don't want to be a part of your continuous integration cycle, of your release cycle. Because also you may decide that perhaps you don't want to monitor this application. So you don't need to maintain two separate code bases or two separate build models, one to build for Spring Insight, another no. So we do load time weaving. That's the power of this solution. If you decide that you don't want us, you just comment out some definitions in the JVM invocation, one moment, and then we're out. We no longer do this instrumentation. Your code just goes back to doing exactly the same way it was used to. Yes, there was a question.
Is there much performance overhead for doing this?
Oh, that's a very, the question was, what is the overhead in total, not only performance, CPU, memory, stuff like that. Since we're using AspectJ in bytecode instrumentation, and since we're only instrumenting the APIs of interest, only those APIs that you selected that you want to monitor have a slightly higher overhead, because when they are invoked, they're not really invoked. We are invoked first. We extract our information, which is kept to a minimum to minimize this overhead, and then we delegate back to you, say, okay, now we can go ahead and do whatever you're doing, we'll just measure you. If you want to be philosophical about it, those of you who studied physics know the Heisenberg principle of uncertainty. And this principle actually states that you cannot measure something without influencing it. So we do influence it. We have every build we do, and we have a lot of integration tests and performance tests that test this overhead. We have some numbers. I think in CPU, we're talking about 5% tops. Memory, we ask for more because Spring Insight is totally stateless. It does not maintain any state anywhere, persistent state. Everything is in memory. We do need some more memory increase. And again, there are, when you use this product, there are recommendations how much memory you should add, but it is a valid concern, of course. Well, like I said, to summarize this, our main impact is usually in memory. Okay, it's less in CPU, it's some in CPU, because we do try to maintain the CPU overhead to a minimum. We don't want to impact your response time. But I'll talk about the impact in some other locations when I talk about what Bootstrap is actually doing. Okay? And the third thing that we do, and like I said, HTTP is very major in the application world. Many applications expose some kind of HTTP facade to the world. We give it a very special treatment because you want to be able to correlate HTTP request with what is going on in your code. You say, whenever the user accesses this URL, something is being triggered in my code, this call event sequence, and this is, it takes me 5 seconds to reply, and this is unacceptable. Why is it taking 5 seconds? Is it the rendering of the JSP that is taking too long? Is it my query to the database? Or is it my access to some file that is being locked or something and I'm waiting too long for it? Okay, so these are the three main concerns. There are other minor ones, but whenever we need to add support for a new server, like my colleague did for WebLogic, these are the three main concerns that we need to address. Okay? So, like I said, like the gentleman here asked, we try to be as unobtrusive as possible. Like in medicine, first do no harm. Okay? Like I said, we cannot avoid the impact, but we try to minimize it. Now, unobtrusiveness can be at several levels. Originally, this Spring Insight solution was designed to work with, those of you who are familiar, there is an application server called vFabric TC server offered by VMware. Originally, it was intended to work with that, and the way they achieved it there is they replaced the entire ClassLoader mechanism with their own. They did intervene very much into the very heart of the application server. They changed configuration. They did a lot of stuff to do that. Now, our purpose in what we call the Bootstrap instrumentation is to be as unobtrusive not only in CPU and memory, but also in the changes that you need to do to your configuration files, to your scripts that run the application, so that if you want to install us or uninstall us, it should be as painless as possible. Okay? And we do that, like I said, by using aspects for almost everything. Not everything. There are some things that we need you, for example, you need you to define something, to add some system property to the JVM invocation command line, or maybe add one jar extra to your class path sometimes, but that's about it. We try to keep it to the minimum. So unobtrusive is a very important goal. But like I said, there are some things that we need you to do. Now, since we're using bytecode instrumentation, we use what's called the Java Agent Weaver option. Those of you who know, this is the JVMTI API of Java, the JVM tooling and instrumentation. And we recommend that you add some system properties. We do have some defaults for them. For example, we do have an installer, a Groovy-based installer, that you can just run it as a command line or as part of an installation script, and it automatically detects the application server, and it knows what you can, and it configures, makes these changes to adds the system property, adds the Java agent option, adds sometimes in some application servers you may need to add some invocation arguments, maybe need something added to the class path, a jar or something, but that's about it, and it also uninstalls. You don't have, it's not only an installer, it's also an uninstaller. So it knows how to revert all these changes and give you back your application server as if we were never there. By the way, there is another option that our installer isn't actually supporting, and what you can do is you can install us but not activate Spring Insight. To activate it is very simple, but that's something that you have to do manually. So you can say, well, I want it installed, but I don't want it to be active right now. Whenever I need to activate it, I'll just reboot my application, add a command line flag, and it will start working. Okay? Like I said, we try to be unobtrusive, but sometimes you come across real life. It's nice to live in theory, but in real life. And one interesting issue is, for example, there is an issue in Apache Tomcat that you hear the number 49987. Basically, it's a race condition in the way that the WebXML servlet context initialization parameters are parsed. Okay? This is a known bug in Tomcat. It exists in all Tomcat releases below 6030. It was fixed in 6030 and below 704. Now, we came across it by a very interesting chain of events where one customer installed it and started saying, well, whenever I install Insight, my application fails to load. Your code is, adding bugs to my, and we kept saying it's impossible. We're not modifying your code in any way. We're just instrumenting, the calls before and after they're being called. How can you do that? Turns out that, like I said, the Heisenberg principle of uncertainty works. And what happened is Spring Insight, for some reason, increased the chance of this race condition. It just exposed it. It did not cause it. It just exposed it. It became more likely. And for some reason, that specific application for that customer, it became very often. The timing was such that the race condition almost always occurred. So we have a special patch inside the Tomcat instrumentation that we wrote that actually fixes this bug. So we are unobtrusive, but real life, so we are obtrusive here. There are some other minor places where, for example, my colleague here will show you, sometimes you come across limitations of the Java language specification, and you have to go around it. There are some classes that you cannot instrument directly. You have to instrument them indirectly, and the way to do that is to replace them, so to speak. We don't actually replace them, we just create a new class that is derived from the original one because of the limitation, and we instrument the new one instead, stuff like that. But again, like I said, we try to keep this impact, this intrusion, to a minimum. And like we said, there are some JVM limitations. For example, another location where you suddenly might see us is in exception stack traces. When, for example, your program throws an exception and it was inside the call flow that is being monitored by one of the plugins, you will see the plugin's call stack, which is usually one more element inside it. You see an aspect closure or something inside, before, after. So you start seeing some strange quote-unquote stack trace elements, you see ours. Okay, we cannot do anything about it. It's built into the JVM. We cannot modify the stack trace when an exception occurs. Okay. Some other interesting stuff. If you're using wildcard resources to load your Spring contexts, again, you might suddenly see our beans in there. Our beans are usually harmless. Okay, they don't do anything. But for example, you might start, if you're counting beans, a bean counter, then what you're actually doing is starting to see a few more beans from us. It's usually not an issue because we try to adhere to recommended good practices, and in Spring, it is not a good practice to use, wildcard, just load wildcard resources. You might use some known prefix or something. All my application context star something asterisk. Okay. But like I said, up until now, we have not found any conflicts or problems with this. So the main concern when starting to add support to an existing application server is the class loading issue. Obviously, we do instrumentation. Instrumentation means we need to examine the bytecode of each loaded class before it is loaded into the JVM in order to be able to modify it so we can intercept it if it's interesting. If not, we just pass it along as it is and extract the information we need. Now, aspects, for those of you who might maybe not familiar with them, are just Java classes. They have to adhere to the same Java classes regulations and specifications like everybody else. So they need to be loaded by someone. Now, because they reference your classes, they need to be loaded by what we call the closest class loader to the loader that loaded your class. Okay? Basically what it means that each class loader, as you know, might have its own way of finding out classes. A class loader is actually getting the name of the class and says, just bring me the bytes of this class that I asked you to. Now, there is no standard in Java to say how classes should be loaded. How should I look up for a class? I can go parent first, child first. I can say some of the classes are parent first, some of the classes are child first. My colleague here, Talya, met with such crazy configurations in WebLogic and other servers as well. So we have to figure out for each application, since there is no rule, no standard in Java, each application server we have to tailor an aspect or a series of aspects that know how this class loader is looking up classes, how your application classes are loaded, and then make sure that our aspects are being defined by either the same one or the one that would be just before it, the almost immediate parent if possible. Okay? And this is a very big issue when we talk about other more complex class loaders, and I'll come to it in a moment. But for example, here's another interesting stuff if you don't know about JBoss. If you look at the class loading hierarchy for JBoss, it looks almost flat. Okay, you have the bootstrap system, the lib, and one more or two, but it's misleading. What JBoss did, they built their own hierarchy of class loading, which is parallel. Okay, it's called the class loading domains and class loading modules and class loading policies and stuff like that. And they could be very deep hierarchy or stuff like that. So what we had to do there, we did not instrument the class loaders, we instrumented the policies, because they are the ones who are actually doing the loading. Okay, so since there is no standard, we need to tailor each aspect specifically. You see here, for example, the differences in the class loading hierarchy between Tomcat 5 and Tomcat 6. And again, we have to be aware of them because we need to instrument the classes correctly because of the aspects.
And the reason you need to do that so you get the most accurate?
No, it's not most accurate. Like I said, an aspect is a class. A class in Java. Java doesn't know what an aspect is. Okay, an aspect is just another class, has a strange name, but it doesn't really matter. So if my class is accessing one of your classes, I'm bound by the Java rules of class loading. I can only access a class that has either been loaded by the same class loader as myself or one of my parents. I cannot access a class that has been loaded by one of the children. because I have no visibility into the class loader. Okay? And since, like I said, our aspects don't only measure how long your method took, that would not ever require that. We also sometimes extract information. For example, if you remember the pet clinic, we showed you a bunch of SQL sequence of SQL statements. So we not only intercepted the method invocation, we intercepted, for example, the JDBC statement call, and we had to extract from it, for example, the SQL and the database URL to which it was intended.
So these are the same rules that you would have if you were using any other library. You would not
Yeah.
put it in the child.
Yeah, a library, because an aspect, the only difference is that it's not, the aspect is not a library, is a dynamic class. The bytecode is generated in runtime and just defined using define class. It's defined, but it has to be defined on the correct class loader because it needs to access. So it's just simple Java class rules, how you access a Java class. So in this context, for example, if I were to load the class from the Tomcat 5, here the Catalina, what we call the Catalina part, I would need to have these aspects defined by the same class loader that handles all the classes loaded by Catalina. Okay? Now, as I've said, class loading in complex servers is complex itself because in many application servers you have what we call common APIs. Common APIs, we distinguish between two actual types of APIs. We call lib folders and bin folders. Again, it's just a traditional name because initially we started with Apache and that's where it placed these common APIs. The first common API is, for example, you have a JDBC driver that, you have 5 applications deployed on your application server and they're all using the same JDBC driver. You don't want to pack it in all your wars. It makes maintenance different, version maintenance, version control. If you decide that you want to upgrade your JDBC driver, you don't want to go to all your wars and repack them and stuff like that. So you can place the JDBC driver jar, which is a very good example, outside your wars, where in a common location. We call it the lib location, again, because traditionally in Tomcat and also in JBoss, that's where you'd put it. In JBoss, there are actually other locations as well. It's just an example. So in the Tomcat, the lib folder. As you can see, in the JBoss, there are several locations. We have to instrument these as well. They're usually loaded by a different class loader than the one that is loading your application, at least in Tomcat and JBoss. They're different class loaders, actually different classes. Okay, some of them. So we need to instrument them as well, because if you are doing a call, one of the classes calls a class that is outside its application, we still need to instrument that outside. The most challenging one is, of course, what we call the bin classes. We call bin classes all the classes that you added to your class path in the command line, the minus class path. Okay? Again, this could be some external third-party library jar, something that there is a plugin in Spring Insight plugin that needs to instrument it. So it's another issue. These are the toughest to instrument, okay, because the class loader that does it is the system class loader. The system class loader is a built-in Java core class loader, so instrumenting it is a bit more difficult. Not impossible, just difficult. Okay? So this is another challenge. And I was talking to my colleague, we just talked about something, we encountered this challenge in WebLogic, okay, especially with a JDBC jar. So this is the major part, the major stumbling block of adding instrumentation is the class loading issue. Once you've done that, you're about 60% done, 65%, you can start now addressing the other issues. And if you remember, the other issue was HTTP access instrumentation. Like I said, HTTP currently is a very important protocol. It is used to expose APIs, not only UI, but also APIs, REST, SOAP, JAXB, whatever. Everything is exposed now everybody is asking, do you have a HTTP REST API or something like that? So since it is so important, we want to be able to instrument specifically and extract more information than, because HTTP requests are not calls, they're not methods. You're actually invoking a URL, giving some headers, giving some body, some content, getting a response, getting some other headers back, getting some other body or content back. You want to be able to show you not only that this has occurred, this HTTP request has occurred, but also extract important information. For example, there is a metric that we calculate which is called request size and response size. You can get a graph that shows on the average this URL is posting this amount of data and getting back this amount of data. Okay, two separate metrics. Also response time. How long did it take from request to response? Where did this time go? And some other important issues. Now, we need to intercept these HTTP calls at the highest possible level. What do I mean the highest possible level? We need to intercept it where the application server knows which application is going to handle this request. The reason for this is that applications are an important entity in Spring Insight. Okay? When we associate a metric, we associate it not only with a specific API, but with a specific API inside an application. Okay? For example, we have a plugin that intercepts all the Spring-related calls. Anything that you annotate as @component, @service, @repository, we can intercept this if you wish. And we can say, well, your @component was called or something like that. But which @component? The one from travel, the one from pet clinic? We don't want you to just, guess from the name of the class or the name of the package what application it was. Again, the application might be packaged. It might not be called, it might be called travel or pet clinic or whatever. So we need to associate this URL to an application. So we need to be as high as possible, intercept this as high as possible. Now, for those of you, I'm sure that most of you know, but I'll go over it anyway. The way an application server decides what to do is it accepts an HTTP request, it parses as much as it needs to just to decide which application is going to handle this request. Then it loads this context, the servlet context and stuff and anything, and allocates a thread and says, now you handle it. Once it is done, it gets a response back and sends it. Now we need to identify the exact location where this code flow crosses from the general part of the server to the specific application, because we want to associate what happens now, the call flow from now on, to that application. Okay? So it has to be high. When I say, and trust me when I tell you that if it's not high enough, you get some strange results, because some servers, for example, have some internal logic that says, oh well, you threw this exception, I'm going to change the code from 200 to 505, I don't know, internal server error or something. And we want to show what the user would see. The user, you might return 200, but 200, everything okay, but some internal API might decide, no, it's 505 actually, because something else was violated or something, some other constraint. So, and we want to show what the user would get. The user would not get an okay, it would get an internal server error. And you can see here, for example, the Tomcat valve model. That's why we call this, like you said, we started from Tomcat and evolved to other ones, so we call it the valve model. In Tomcat, those of you who are familiar know that valve concept, where things go in, and there's a valve that decides who's going to handle it, and then it receives it back. So we need to intercept the valve at the right place. Oh, sorry. So once you've done class loading, you've done HTTP, you're about 85–90% done. There are still a few issues that we need to resolve, and I'm going over them. Again, they're important, but in our experience, they have not been the biggest stumbling blocks, the biggest problem. They're usually the quickest that you can resolve. And like I said, application lifecycle events. What we actually are doing is we identify how the application server is deploying your application. What does it do? What is the call sequence? How does it identify the file, the WAR file? What does it do? How does it start your application and then invokes the servlet context initializer or stuff like that? Please note that the application events that we generate are even before your servlet context is being called. We're actually telling you this application is about to be deployed, is about to start or something like that. And following that, as you've seen in the pet clinic example, the application lifecycle start, you can start seeing, once my application is deployed and my servlet context initializer is being called, I'm doing X and Y and Z, and this is why is this taking so long to come up. Okay? Because, as you can see, there's a small note that says not all events are generated for all servers, and the application start event is generated for all of them. But some servers do not really do, for example, undeploy. Okay? Or when they do undeploy, they do it in a very I would say brutal manner. They just delete everything inside. They don't generate an event. They don't, and it's very difficult to identify. And not only that, but most of the applications we came across don't do what is known as hot deployment, because there are so many problems with hot deployment where you undeploy and deploy an application without really restarting the application server that we don't see that much. But again, if ever it becomes good, and we follow these things, if it comes a common practice to do hot deployment, undeploy and redeploy, stuff like that, we will, of course, generate the correct events. And again, the bootstrap instrumentation, as you can see, must catch these events at the right time. What is the right time? It is when we know what application it is. Remember, the application is a very important entity. Is a centric entity inside, because that's what we associate everything with. The metrics, the call stacks, and all the other stuff. So we try to find the soonest location, the highest location in the deployment process where we know what the application is going to be, and then we can generate the event and say, oh, this application is about to be deployed. Okay? Oh, sorry. Since I've talked so much about applications, how do we name them? Another of the duties of the bootstrap instrumentation for a specific application server is to decide how to name the application. Now, because of some historical reasons and for standardization, let's say, considerations, at the moment the name of the application is derived from the war file. Okay, if your file is called travel.war, your application is going to be called travel. We're looking into modifying it slightly into using the context name of your application, not the file name, because in many application servers you can, my file can be called whatever, but when I expose it, it will be /travel or /petclinic. And it makes more sense to the user, or be it the developer or the operations administrator, that the application is actually travel. It's a traveling application. I don't care what the name of the file is on the disk, okay? And we're looking into how we can actually do that. For now, it is coming. Another important challenge that we had with this application name has to do with enterprise archive applications. Originally, like I said, it came from vFabric TC server, which is actually Tomcat on steroids. And then we developed the Tomcat and JBoss and others. And in all of them, except for JBoss, there was only a WAR file, a web archive file. So it made sense. But when you go into an EAR file may contain several applications all packed into one super application. So how do you name this? And specifically in WebLogic, we came up with a naming convention by which the EAR comes first, the name of the EAR or the application, the packaging comes first, and then it's followed by the actual sub-application, because you might have two travel applications, one packed inside one EAR, which is, I don't know, flights, which is one kind of travel, another, cruises, also might have packed inside the travel application. So you want to have flights.travel or whatever naming convention, and cruises.travel. That's the actual application. And again, we're looking into how to do that. Now, I'm going to yield this to my colleague here, who is going to show you how she had to deal with all these concerns when she had to implement it for WebLogic. So, Talya.
Thank you. Can everyone hear me okay? Okay, good. So, hi, I am Talya, like Lyor said. And I will be discussing take my notes here. I will be discussing with you the main challenges that we came over when we were working on WebLogic. Now, the point of this is one for you to appreciate the kind of things that we actually have to tackle when we're doing this. And also hopefully be able to understand what are the main things you should think about if you ever want to POC your own favorite application server and instrument it with Insight. So just to recap on what Lyor talked about. The three main points of interest that we have to notice when we come to instrument a new application server are as follows. The first one is instrumenting all of the relevant class loaders, which means adding our collection plugins to the class path. Now, as Lyor mentioned, most of the interesting challenges that we encountered with WebLogic were actually related to this first bullet. And this is because WebLogic has a relatively complex hierarchy of class loaders, and they have some interesting features related to class loading. So I will be spending most of my time diving into this bullet. The second one is handling lifecycle events and application names. I will touch briefly upon that towards the end. And the last one is intercepting HTTP request and response handling. Now, as Lyor mentioned, and one of the interesting anecdotes we have about WebLogic for the third one with the HTTP request is, as Lyor said, it is very important that we catch the HTTP request at the earliest point when we know what the application is. Now, one thing I started noticing when I was working on WebLogic was that for some reason, every trace that we showed, even if the server threw a 500 internal error, was showing the same status, which was OK 200. Now, this was kind of weird because I was using Chrome developer tools and everything, and I was actually seeing the 500 error there, but we kept saying 200, and I mean that number had to have come from somewhere. We don't have a default saying 200. So I started tracing the code of the WebLogic. And actually, the solution ended up being pretty simple. What happened is, from the POC, we had this code that was instrumenting the point cut that we were using for the aspect was just a few levels too down. We had this like whole call stack, and we were catching a method just 2 levels lower than what we actually had to do. So I simply changed the point cut to catch the method 2 levels above, and that solved it. Now, it's not very interesting per se because unless you're actually writing the code for WebLogic, you don't care about this. But it does go to show that it's important for every application server that we instrument that we actually understand the intricate details of how things like HTTP requests and response are handled and lifecycle events. So with that, I will... Oh, OK, one sentence about the way we actually perform this instrumentation. What does it mean when I say we need to add the collection plugins to the class path of each class loader? What we actually do is we have this aspect. This is relevant for all of the application servers, not only WebLogic. We have this aspect that intercepts the lifecycle event of some application. For WebLogic specifically, this is the web app module init method, but it could be anything else. And then we start following the class hierarchy upwards. And for each class loader, we actually insert all of our collection plugins to the list of the URLs that this class loader is supposed to load. So this is how we actually go about injecting all of our collection plugins to the class loaders. Now, in order to appreciate why we have interesting issues about this class loading, I will first take you through the mechanism of WebLogic. What does it actually mean when I say that it has a complex hierarchy of class loaders? So this picture is the first picture that you see if you start looking for the documentation that Oracle has for WebLogic. And what it shows is a pretty straightforward picture. We have the system class path loader, as in all Java cases. And then below it, we have a separate hierarchy of class loaders for each application, for each EAR file in this case. Or it could be a WAR. And what we see here is that there is the application class loader for all of the EJBs or other things that the application contains. And there is one class loader per WAR file, per web application. Now, these are segregated into different hierarchies. And as we discussed before, each class loader, of course, has visibility into the classes loaded by itself or by any of its parents. The opposite is not true. We cannot have any class loader accessing classes that were loaded by any of its children. So this is the big picture that actually enables WebLogic to host multiple applications inside the same JVM. So in fact, this looks like a pretty straightforward picture. There's nothing new about it. But the thing is, when we start diving in, there are actually quite a few more class loaders and mechanisms in place here. The first is something that's not specific to WebLogic. We, of course, have the BootStrap ClassLoader, which is responsible for loading all of the core Java classes. We have the extensions ClassLoader for anything that extends the runtime. We also have the shared lib ClassLoader, which Lyor mentioned before. In WebLogic, there is a folder actually called lib, and there is a ClassLoader created for this ClassLoader. Its type is java.net.url ClassLoader. And anything that the user throws into this is simply loaded and kind of appended to the class path loader, but actually under a different class loader. And all of the applications have visibility into this. Now, this is where it really starts getting interesting. One mechanism that WebLogic has, an interesting feature that is implemented, is a filtering class loader. What this enables the developer to do is to actually configure a specific name of a class or a regular expression which includes multiple classes, and say for this specific class I want to override the default parent first behavior and I want to have a child first behavior. So going back to the JDBC example, a developer could specify for a specific EAR file, this is configured by editing a specific XML file that is packaged within the EAR or inside the WAR, but it doesn't really make a difference. And he could say, I want this specific JDBC jar to be loaded by my application class loader, by my web app class loader, instead of actually being from this EAR or from any place above. And of course, let's not forget that we can have multiple applications sitting on the same system class loaders on the top. So this is actually the full picture. There is one extra nice feature, which is called child first, which is similar to the filtering class loader, but it is a bit different. And what it simply does is it says this application behaves totally as if it is child first. Okay, unlike the filtering class loader, which is customizable, it just does it for all of the classes. So what is important to see in this picture is that, in fact, when you actually have an application up and running in the WebLogic container, and there may be other EARs and other WARs that you are not necessarily responsible for, if you actually want to know now in runtime which class loader is going to end up being the one that loads the class that your code is currently trying to use, it's not very obvious necessarily from just looking at your code what is actually going to happen. It could be any one of these class loaders, and it could actually, the class could reside in even several of them, and you don't necessarily even know or are aware of all of the logic that is going to actually decide this. In fact, this is apparently so complicated that WebLogic Oracle themselves implemented a debugging tool, which is called WebLogic Server Class Loader Analysis Tool. This is a very good descriptive name. This is exactly what it does. And in fact, this was so useful for me. I spent so much time using this application while working on WebLogic that I would have probably ended up implementing something like this for myself if it hadn't existed. Granted, with not such a nice UI, but still, would have probably ended up writing this kind of stuff to the screen. So what we can see here is on the left-hand side, we have the list of all of the applications currently loaded by the container. You can see, for example, there are some internal applications like the console app, which is the administration console, and also user applications. This is my favorite demo application. The name of our QA guy, this is why his name appears here, Boris, in case someone is wondering why. On the right-hand side, we can see for any selected application the list, the hierarchy of all of the class loaders. As you can see in the top area, we have the system class loaders, and on the bottom we have the application class loaders. The top part will always be the same for all of the applications in a given container, and the application class loaders will be different. Now, one interesting option we have here is the detailed view. If we click on the detailed view, all of this list will be expanded, and each class loader will display a whole list of the classes, not of the classes. It will display the whole list that it has on its class path. Okay. There is another option where you can click on a specific class loader, and then you will receive a view dedicated to this class loader with an actual list of all of the classes that have, in fact, been loaded during the runtime of this application. So you can actually tell which classes have been loaded by which class loader. There is another interesting option called Analyze Conflicts. Now when you click this, you get this report of all of the potential conflicts which actually consists of a list of all of the classes that could potentially be loaded by more than one class loader. Now, this does not necessarily mean this is an issue, but it could be an issue. And usually it suggests a way of fixing it, which says go and configure the filter class loader and decide which one of these should actually load the class loader. So, why am I showing you all of this? Okay, so we've determined that the hierarchy of the class loaders in WebLogic is more complex maybe than Tomcat. But why do we care about this? What does it matter? We've already discussed the fact that we inject all of our collection plugins to each of the class loaders. We know how to do that. So even if the hierarchy was infinite in theory, why do we care about it? So we will now follow a specific flow of the application code, which will demonstrate why this is important, why we actually care about knowing about this, and it will also illustrate what Lyor referred to before about the fact that making sure that our collection plugins are loaded from the closest class loader, why this is crucial, okay? So let's have a look at this theoretical application. Let's assume that we have a child class loader, which is the var class loader, and the parent class loader is the ear class loader. And let's assume that the JDBC jar is packaged in both of these. For example, because, I don't know, let's say there are 5 other war applications under this ear, and all of them use the same JDBC version, but specifically this war, for some reason, needs a newer version, or an older one, whatever. And as we've discussed, we have already added our collection plugins to all of the class loaders, specifically these 2. Also, let's assume that the user has configured here a filtering class loader for the JDBC, because this is what he actually wanted. He wanted the JDBC for this specific application to be loaded from the application class loader. So let's assume the application is now running and it actually hits the point where it wants to execute a query to the database. Which class loader will be responsible for actually calling the JDBC API? It will be obviously the child class loader. This is why the developer configured the filter. Now at this point, our code comes into play. Our aspect, which is supposed to instrument the call to the JDBC, will be executed. Now, the default behavior for this is that the parent class loader will load our aspect. Because it exists in both of them, the default behavior is to ask the parent class loader for the code. Now up to this point, everything is okay. But what happens next is that our code, as Lyor mentioned, in the JDBC plugin and actually in most of our plugins, usually creates calls back to the API, because we want to be able to show you in the trace as much data as possible. We want to be able to show you the actual query and whatever is relevant for the specific technology that we're instrumenting. So at this point, our aspect is going to call back the JDBC plugin, and it's going to be the same one as before, the one in the child class loader. This is the point where the general rules of Java classes come into play. This isn't something that we can do. So if we had stopped at this part, we would receive class CastExceptions for any collection plugin that calls back to the API. And this is not good. Now, I do want to emphasize that this is not good for us. For the application, it is fine, because we do have a mechanism that catches this. For any runtime exception, we simply make sure that the user's original thread continues to run. The application is not affected, and we even go so far as to disable the specific plugin that caused this. So it will not happen again. But it also means that we will not be able to show any JDBC calls. Okay, we will have a trace, and no one will see what happened in the database, which is bad, because that's what our product is supposed to be doing. So we had to find a solution for this. Okay, now the obvious thing here, once we actually understood the problem, was to use the same mechanism that WebLogic implemented. We have the filter here, which was responsible for the JDBC being called from the child class loader. So what we do is we add to the filters all of our collection plugins, and then our collection plugin is called from the child class loader, which is the same class loader as the JDBC. And then everything is okay. Now, the way we do this is we have a simple aspect. We catch the filter and class loader of any web application that we have decided we want to instrument, and we simply add a regular expression for all of the inside collection plugins. So, is this enough? Obviously, since I'm asking, it's not enough. One of the next problems that we encountered was this fact. For some reason, which I'm not completely aware of, but the filtering class loader does not always exist. Okay, WebLogic, sometimes, it depends on the version. It happens mostly on 10.3, which is the major version that is around of WebLogic, less so on 12.1, which is the new cloud-ready version. But even on 12.1, it happens sometimes. It seems to have something to do with the packaging. It happens more if you package the ear in a specific way. But it's not something consistent, and it's not something that we want to rely on, because it's very important for us that our code always works. We can't just discover this at runtime. So our solution for this was to actually take the relevant class loaders. In this case, it is the change-aware class loader, one of the class loaders that WebLogic has. And we actually change the way it behaves. We instrument it, we write an aspect, and we make it behave as if it is child first, as if there is a filter in class loader above it, even though there isn't. So what we have here is this short code sample, just so that you get the gist of the way we do this. This is aspect J syntax, and this is the definition of a point cut. For those of you who are familiar with it, you can just go ahead and read it. For those of you who are not, the main thing to notice here is that we catch the execution of every call to the load class method of the specific class. We actually have another one for the other class of WebLogic, but what we do is we catch every single call to load class of change-aware class loader, and then we modify its behavior. We modify its behavior to behave as if it is parent first. Now, this is the code of the advice, of where we actually modify the behavior. The important part here is not how we modify it, but it's what I want to show you is how we make sure that a very specific set of conditions is met before we actually make any changes, because, as Lyor mentioned, we try to do as little as possible. We want the code to be as close to the origin as we can. So the first thing we check is we check that there actually doesn't exist a filter in class loader as a parent. If it's there, we don't have to do anything. It's going to take care of itself. The second thing we check is that the class loader isn't defined as child first, because once again, there's nothing to fix in this case. And assuming these two conditions are met, the last thing we check is that the class being loaded is actually one of our classes, because we don't want to affect anything else that is not related to our classes. Once all of these three conditions are met, we go ahead, we change the behavior, and we make sure that we load the class from this class loader. So, going back to the original picture of all of our class loaders. We've injected our collection plugins to each of the class loaders from this one all the way up to the system class path loader. And we've also fixed the behavior of the ear and the var class loaders to make sure that they are filtered even if the filter does not exist. We've added all of our collection plugins to these filter class loaders. And the question is this enough? Is anything else left that has to be done? And this is the one question that remains. Because this class loader sits between the system class loaders and the application class loaders, it can in theory have exactly the same issue as before with the class CastException. But it does not have a filter above it. Now, the obvious solution for this is doing something very similar to what we did before. We want to modify its behavior and make it behave as if it has a filter. It's the same solution. But there is one small issue with this. And this is something I think that Lyor referred to before as well. The URL class loader that sits on this level is a core Java class. It means that we cannot instrument it the way we instrument the other WebLogic classes, because it is loaded from here. And aspect J does not have visibility into this. Now, we could have in theory written a point cut which would instrument and catch all of the calls. Instead of instrumenting the call, the execution, instead of instrumenting the execution of this load class, we could have written a point cut which uses the call syntax of aspect J. That is possible in theory, but the problem with that is that it is more expensive. Okay, if we instrument an execution of a specific method in a specific class, then aspect J just has to weave that class and change it a bit, and it's done. If we want to instrument any possible call to it from any class, the code there has to be, it's heavier, it's more expensive because it has to examine every call to any class and method. So we took a different approach to this. And what we did is we created our own class. It's called Insight URL Class Loader. And all it does is simply extend the URL class loader, and we override the load class. Now this override is, it does nothing. All it does is actually call super.load class, and it's done. But we use a different aspect to catch the point in time when this URL class loader, the specific instance of it, not any URL class loader in the system, is created. And we use an around advice to actually replace that instance with our own instance, with our class that has this override in it. And once we have done that, we can use the exact same solution from before and write an around advice with a pointer that catches the execution of this method, and the same solution applies. So, I think we've had enough about class loading now. We have multiple other examples of interesting stuff that happen with class loaders. Double beans showing up and stuff, but I think the main concepts are clear here. What I want you to remember is that it's important to understand the whole hierarchy of the class loaders. You need to know which classes are in play. You need to know the way they play with each other. You need to be aware of mechanisms like filtering or anything else that happens in different application servers. And this is the reason that when we come to Bootstrap, a new application server, we don't exactly know in advance what's going to happen. There isn't one recipe that can be applied. There are general concepts you can try out, but you're probably going to have to figure out most of the implementation of the specific container. How are we doing with time? Yeah? Okay. So, going back to the list of the 3 things that you have to take care of in order to bootstrap. The first one was the class loading issues, which we covered. We had the HTTP handling, which I also discussed briefly, and the last thing is the application names. Now, as Lyor mentioned before, for WebLogic we added something new that did not exist in advance, and this is the reference to the whole concept of the ear. What we have here is an example of it's a real screenshot of a specific WebLogic container running. Now, the first half of this is the same as it is for other applications. Lyor mentioned that we don't use anything except the var name for the application ID. This is true. But the label does, for all servers, not only for WebLogic, contain, and it is made up of the context name and the display name. So in this example, for the same application that I used for the previous example, which is the administration console, what we have is the context name, which is console. This is the last part of the URL. Okay, you actually go to localhost 7001, which is the WebLogic port, console. And we have in parentheses the display name, which is whatever the developer specified in the file. What we have added for WebLogic is the second part, which says here web app on console app. Now, web app is the var name, which sits inside the console app.ear file. Okay. What this actually enables us to do is differentiate between several vars which may be deployed on the same server, and they may have the same name, but we can now actually differentiate between them. Before this, if we had 2 separate var files named web app, we would have displayed them, they would have been aggregated, okay? The metrics, the counts that we would have shown to the user would have been completely aggregated, and there was no way to know that these are actually 2 different applications. Today for WebLogic, we actually show the breakdown of this. One more interesting thing about WebLogic is the fact, if you can see here, we have, for example, the console application and the console help application. Now, for WebLogic, there are many internal applications. These are the 2 default ones. The WLSCat, the class loader analysis tool that I showed you before, is another one of them. If your WebLogic domain is run in clusters, then you have many. in short, you can get to the point where there are 7 or 8 internal services that are running. Now, our user, the application developer who is using Insight, doesn't care about this. He doesn't want to see all of this noise. He just wants to see his one application, okay? So, fortunately, we discovered that WebLogic has implemented this property which was very useful for us. And this ties to what Lyor discussed about the lifecycle event. In the lifecycle event, we have to know exactly what the application class is. We have to understand the semantics of the WebLogic server. So at this point, we have the application context object in hand, which has a numerous amount of properties related to the application being loaded. One of them is the internal application, which is exactly what it sounds like. So we use this, and if this property is true, we just automatically decide to ignore this application. The user can override this with our properties file if he doesn't want to see what's going on. It's actually quite interesting to see the way Oracle implemented this, but not for most users. So in production, these applications by default do not appear. We do not show them. The user will only see a list of his actual applications that have been deployed. Okay, so this concludes my part. What I would like you to remember from this is that if tomorrow you decide that you want to instrument your new favorite application server, there are basically 3 things that you have to keep in mind and be aware of, which are the class loading behaviors of the application server, the way it handles HTTP responses, and this whole issue of lifecycle and application names and what the concept of an application actually is. Now, once you've understood these, you're probably halfway to actually having a minimal POC up and running, because most of these things that we've discussed, actually, we have good support in the framework. Okay, there are basic abstract aspects for all of these, and you usually just have to override them and add a specific point cut saying this is where the ClassLoader loads classes, this is where the life cycle of an application starts. Now, this is not to say that you are close to actually completing the whole thing, but if you just want to have a POC and show, oh yeah, I can make this work with WebSphere, for example, these are the things you have to understand. So with that, I will allow Lyor to come back on stage.
Thank you. Thank you, Talya. I'll summarize what we said is, as you've seen, there are several concerns that come to play when you try to add support for a new server version. And like Talya said, based on our previous experience with other application servers, we've developed what we believe is a very good framework for adding new support more easily than we've done it in the past. That being said, is like Talya said, there are no guarantees, and each application server is a case study on its own. And for example, I have done a POC on WebSphere, but I can't say that we actually support WebSphere. All I've shown is that I can instrument a class being loaded by WebSphere, but it's not like I can actually say that I know what the class loading model is, I know where the HTTP request goes, and I know how applications are loaded, what are internal, and stuff like that. All this has to be resolved. But what I do want you to understand that it's becoming more and more easier to add support to new application servers. Again, we think that we have a very stable framework, and we have a roadmap for adding more support. WebSphere, like she mentioned, is definitely on our radar. We do want to add support for WebSphere. For example, we might add support for JBoss 7. By the way, speaking of JBoss, each JBoss, I don't know what these guys have with class loading, but each JBoss version, they change the class loading model from the ground up, 5.0, 5.1, 6.0, 6.1, all different. Each has its own. I mean, they even sometimes they use the same class names, but they're packaged differently, they behave differently. You cannot port the code from 5.0 to 5.1, and you cannot, not the code, the class loading model and stuff like that. I'm not talking about JBoss 4 and others.
7 is even more different.
Yeah, it's even more different.
Modular class loading.
Yes, 7 is even more compliant with JEE standard. It reminds me a lot of Glassfish. It's very similar, and yeah, and like I said, it's another challenge altogether.
By the way, what's interesting is, unlike JBoss, in WebLogic there were almost no differences. Like the difference I had from 10.3 to 12.1, which I'm not sure exactly how much, but there are a few years in between them. It was really minor. It was just one class where they changed the name of two properties. That was it. So.
And the interesting stuff is that we have an open architecture for actually instrumenting non-Java servers. We have to actually have an ongoing effort of instrumenting .NET applications, the same way we instrument Java with aspects and modifying them on load time and stuff like that, and actually reporting back to Spring Insight, and you'd actually be able to see in our dashboard, for example, or anywhere else, applications coming from .NET and from Java and others, Ruby. Again, we're not doing Ruby, but it's open enough. You can do Ruby, Python, others, which is an issue for another presentation, maybe SpringOne next year. It's called the split agent. So that being said, I'll open for questions if anyone wants to. Yes, please.
Make a comment about App Insight and how it's merged into App Insight.
Okay. App Insight, again, I'm not very familiar. I do know because we worked with them. App Insight is a VMware offer of application performance monitoring. It actually collects data from many, let's say, data sources, Spring Insight being one of them. And it aggregates this data and displays it in a manner that is more useful for operations, administrators, and stuff like that. It shows what is happening in your applications as far as not only code goes, but also network, other, there are other projects that are serve as data sources for this App Insight. And what they do is, like I said, our agent collects data and reports it somewhere. If you're a developer, then by the way, when you download the STS Spring Source Tool Suite, I think even the one before the latest, you get the vFabric with Insight inside. Okay, so as a developer, we automatically configure the vFabric TC server to report to the dashboard. We call it the Dev Edition, the Development Edition. So as a developer, you just put your wars in there, you start working, then you can see the metrics, what is going on, what has gone wrong, why does it take so much. By tweaking a similar installation and telling it, I want you to report to App Insight this information, well, that's all we do. Instead of reporting to the dashboard so you can see a nice UI, we report to somewhere else. Again, the agent isn't aware that this is what it is doing. The agent itself that is running and constantly monitoring your application is just collecting data, wrapping it, sending it to someone else to do something with it. For developers, it's the dashboard. For others, for operation administrators and others, it's the vFabric App Insight. Okay? And they have their own metric store. They will collect all this information, display the metrics, do health analysis, stuff like that. And but we are an important source for knowing, for insight into what is happening inside the Java code once it is invoked. Yes, please.
You store the information that you're displaying inside web interface somewhere for archiving or later referring later?
Yes. The dashboard itself has a persistence.
So you have a database for it?
We have a combination. We use both a database for some things, and we use Gemfire for caching other stuff. Again, the dashboard, it's part of the Dev Edition. You can use it anywhere. Has policies, for how retention policy. I think the default is 7 days. Again, the dashboard is built to work with several agents. You don't have to have one per agent. You can have several agents report to one dashboard. But again, it's not a production grade dashboard, that can support thousands of agents reporting. That's what vFabric App Insight is for. vFabric App Insight is supposed to be the solution for a big data center where you have many agents, tens, hundreds, even more, reporting to a general location that, you know, collects, analyzes, and displays the data, and also correlates it not only from our source, but from other sources as well. For example, if we report that there is a problem with the response time, Up Inside may be able to break it down for you and tell you whether the delay is in the network or in the Java execution. If you're getting a 10 seconds response time in your HTML or something, they may be able to tell you, well, out of these 10 seconds, 6 seconds are in the network. They're not even related to your application. Something in your router or your load balancing is wrong. Okay, that's why you're paying so much, you know, in time. But the dashboard itself, you can have it aggregates information from several sources, and it can display them over time, and it's persisted. But again, it is not intended for production grade. But you as a developer can use it, you know, to, you know, store. Maybe you want to monitor your application for, you know, 3 weeks or 3 days a week or so, and see what is going on, and then you leave it working overnight. You come back and you can see what happened overnight in the history. Yes, please.
So you were talking about how you can put the aspects in on the annotations that Spring provides. Do you
Yes.
provide the same level of instrumentation for WebLogic?
Yes, it doesn't matter. The instrumentation for an application server is totally independent from the collection plugins. Okay? What we do with the instrumentation on the application server is make it ready to run our plugins. That's all. But the Spring doesn't really care if it is running on WebLogic or it's running on JBoss or running on Tomcat. The same for the collection plugins. Our collection plugin that, for example, collects JDBC calls is not specific to any application server. You can use it anywhere you like. Anywhere you have JDBC calls, we can use it. Okay?
So what if they're writing a more traditional JPE app and they're using JSF and
We have
a plugin for JSF.
we have not yet. There's a contribution. It's being reviewed.
I thought it was
It's being
authorized.
reviewed. Yeah. Like I said, we collect APIs of interest. Okay. We have right now, I think, over 30 plugins for many of the most widely used APIs, like Spring, like Spring Core, Spring Web, Spring Webflow, all the major Spring, Spring Data, Spring Integration, Java
Bash,
Mail,
I think.
LDAP, RMI. We even started looking to JCR, Java Content something, Jolt, BlazeDS. She wrote the BlazeDS, and many others. But it's also an open architecture, an open source architecture. The plugins are actually in GitHub. You can get the code, and we have also documentation that explains how you can write your own plugin. You have an API that is not Spring, it's something very special, and you want to write a plugin that collects your API. You can do that, and just plug and play. You have to adhere to a certain coding standard. You have to write a certain XML file or something, and then just put your plugin in a known location. It will start working. Yes, please. Delivery method for the Spring Insight? Yes. We actually, right now, Spring Insight is delivered as a TC server template. It's an installer. The template contains an installer that knows to install on any application server. There is no, I mean, we don't have a distribution for WebLogic. There is one distribution with one installer that knows how to install itself on any target you want. Is that what you meant?
Yeah, the next question is there a way to turn off WebLogic in terms of the applications have a state of, let's say, an admin state and then an administrative state, a different state? Does the Insight plugin turn on and off based on the state of the application?
The question was, I'll make more general. Can you enable or disable Insight based on certain state of the application? Well, we do have ways to enable, disable plugins, collections, either globally. You can say, even though I have the plugin, I don't want you to use it right now. You can even re-enable it, not dynamically because it's weaving. You have to, but you can disable it dynamically. Okay, if you have a plugin that says something. Now we do not have specific tie-ins to application servers. We do not know what WebLogic state means. Okay, if you want, but you have configuration files that you can say, well, I don't even want you to collect, this application is off limits to you. I don't want you to instrument it. Or how you decide to do it is your, but we do have a pluggable way to do it. If you write Java code or Groovy code, we have something called the collection settings registry, where you can, your plugin can hook into, and then you can say, my plugin knows how to get state information from WebLogic, and I want you to disable this and that and whatever. Like I said, it's an open architecture, like Spring. You, in a way, you inject yourself into our code. We can't use injection because we're not Spring. We're working at a much lower level than Spring, but we have some of these concepts, so you can enable and disable plugins. You can even enable and you can even write just fill in an XML file, and you don't have to write a plugin. You write a definition. I want you to start collecting all the API calls to all the classes ending in the suffix service. Any class called anything service, I want you to collect data from all its method. You don't even write a plugin. You fill in an XML and you run it, called the custom AOP.
The option of actually disabling the collection of on a whole application is very easy. There's a properties file, and you just have to write the name of the application in it. But did you mean something specific, though, about the state of the application?
In the console app, you can say, I'm deploying an app and I put it into administrative mode. And basically, the administrative mode saying, I'm not available for public access at this point.
Mm-hmm.
And then change that.
Okay, so we don't have that, but that actually that could be interesting to maybe add. Maybe there's another property like the internal application which could be utilized.
Right. I mean, it's
That's a good idea.
I can see where Spring Insight wouldn't care. And that's a Spring Insight configuration, not talking to WebLogic
Mm-hmm.
service is very specific.
Yes, but you could just go to the properties file and add the name of the application that you just created in that state until you decide that it's not in an admin state. So it's an easy workaround.
More questions? Okay, then thank you, and have a good day.